In this video I'm going to go over setup and calibration of the robot. Assuming you've already got your robot built and the electrical all done, the next step is to load up the Arduino board. If you're not familiar with Arduinos, they are basically just programmable controllers that you can program to do a number of different things. In this case, I've built a program for my Arduino that will send step and direction outputs to the stepper drivers, and the Arduino receives those commands from the computer program. So if you go to the Arduino website, go to downloads, you can download the Arduino software and install it on your computer. Once that software is installed, you can download the sketch file for the robot project. So once you have that folder on your computer, it should be called sketch_Annin robot. So we open that up, and inside of it you're going to find a INO file by the exact same name as the folder. So if we open that up, it will open up the Arduino software and will open up our sketch or our program for the Arduino board, and you can see here the guts of the program that sends the outputs for the step and direction for the program. If we go to tools, we want to make sure that the board selected is the Arduino Mega, the correct board that we have, and we'll take note that it's on COM4. So at that point we can just hit upload, and what that will do is it will start compiling the sketch, and then you'll see some lights flicker on your Arduino board, and it will start uploading the program to the board, and it will say done uploading. So now the sketch is on the board, so we're done with that. Now as far as the control program, there's two ways you can open it. You can either go to the latest releases and open up, download the executable file, which is the easiest way to do it. The program will just open. You don't have to have Python installed. Or in this example, I've got the source code folder that I've downloaded. So I'll open up that folder, and inside of it you're going to see anninrobot.py. This is programmed in Python, and that's the Python source code file. If I right click on that and open it with a text editor, you can see the guts of the program. You can get in and play with it, mess with it however you want. The other thing is, if you're playing with a source code file, you of course have to have Python installed. So you'd want to go down and download Python, the version 2.7, and that should include the TK module and any other modules you need. And then you also need the PySerial module, so you need to download the PySerial module. So once you have Python installed and the PySerial module installed, you can open up the source code file, and it will run just like the exe if you downloaded the executable. And I am running version 2.7.11 of Python on my computer. So when I double click that and open up the program, you can see over here I've got my PortCom program name, program control buttons, my program area here. I'm going to go ahead and delete that for now. I was playing with that earlier. And then we have our function buttons that will throw functions into our program. But what we're going to be concerned about today is up here. We're going to be looking at setting up the calibration of each axis. So the first thing I want to do is change that to port COM4. So we took note earlier that we're on COM4. I can hit set COM. You should see a couple lights flash on your Arduino board there. You should only have to do this once though. Next time you open the program, it will automatically set the port COM for you, so you should only have to do that once. Now we get over here into actually calibrating the robot. We've got a number of fields for each axis. We've got step limits, angle limits, degrees per step, calibration angle, current step, current angle, steps to jog, and then the buttons to jog the robot. So the fields highlighted in blue are ones where you need to put in entry values that are part of your calibration. The black ones highlighted in black are calculated by the program, and you should only have to mess with these one time here when we do the calibration. After this point, after you get it calibrated, the only thing you'll need to change is steps to jog. Now I've written this for the sake of simplicity. When you jog the robot, you're jogging it by steps of the motor. So most stepper motors are 200 steps per revolution. So if I was to hit forward right now, if I was to click on the plus button, it would jog the axis one motor, one full revolution. Now each of these axes of course are geared differently, so that's going to mean something different for each axis. Axis 1 is geared pretty high, so one step is going to move a pretty good distance, whereas J3 is geared very low with that 5/16 fine thread rod, so 200 is not going to move it very far. So you're going to have to play with how far you want to jog each axis, and of course as you start jogging the robot smaller increments and get closer to your target, you'll be stepping this down, and then of course changing your speed, lowering your speed to avoid crashing the robot. So moving on with the actual process of calibrating, the first thing we want to set is our angle limits. This is how far we want the robot to move all the way left and how far we want the robot to move all the way right. I've set up the program when it first opens, it sets it to 0 and 360, and then gives you some really high step limits of 0 and 20,000, higher than you'd ever need. So as far as angle limits, we're going to start with axis 1. So 180 degrees is the center of the axis rotation. So right here where I have the robot, right here, right in the center of its rotation, that's going to be 180 degrees. Now if I could rotate the robot all the way back, that would be 0, and if I could rotate it all the way this way, that would be 360, but I didn't make my wire loom long enough. I only made it long enough that I can go in 90 degrees in either direction. So what I'm going to do is I'm going to program my robot's working area to only be from 90 degrees here over to 270 degrees here. So that's what I'm going to put in here for my angle limits. I will put in 90 and 270. Now the next thing I need to know is the step limits. I need to know how many steps it takes to go from 90 to 270. So right now I've got my robot powered off so that I can move it around like this. So what I will do right now is I will turn the robot on. I'll power on with it in the 90 degree position right there. So now my robot's got power, I can actually start jogging it. I'm going to take current step. You can see the current step, assuming that it's at 180 degrees with 20,000 steps, it puts it right in the middle at 10,000. So I'm going to change that to 0, and then I'm going to jog my robot all the way around from 90 degrees over to 270 to see how many steps that takes. I'm going to slow the speed down because axis 1 is geared pretty tall, so it's going to move faster, so I'm going to put that down to the speed of 25. And I'll change this to 2 full revolutions of the motor, 400 steps, and I'll hit the plus button. And I'll hit it again, and I'm just going to keep going until I get around to 270 degrees. So 24. So I'm now at 2,800 steps, and I've gone too far. It's past that, so I'm going to go back 200 steps, go to 2,600. So right there I'm exactly at 270 degrees. So it took 2,600 steps to do that, so I'll put 2,600 in this field up here. Okay, and then I'm going to jog the robot back to center, and we'll start working on axis 2. Now again, axis 2's limits are not going to be nearly as far. 180 degrees is considered the axis in the center of its stroke being straight up and down. If I go forward, that's going to be less than 180. If it's going to go back, it's going to be greater than 180. So what I want to do now is figure out what those angles are. So to do that, the first thing I needed to do is get axis 3 out of the way. It's in my way, so I want to rotate axis 3 up. So I'm going to put this to maybe 600, change the speed to 100, and move axis 3 up. So I'm just keeping an eye on the joint there to see when it's as far as it can go. I'm pretty close now, so I'm going to change that from 600 down to 100. Okay, so that's as high up as axis 3 can go. So now I'm going to go back to joint 2, and I'm going to jog it down as far as it will go. Let me move axis 1 back to center a little bit here. There we go. And I'll slow the speed down to, let's say, 25%. And then axis 2, we're going to jog it down as far as it'll go to its minimum. Okay, so I'm getting close. I'm going to turn this down to 50. Okay, so now I've just touched the table. I want to come up just a hair. Okay, so I'm just off the table. So that's as far down as I can go. So now I want to get out my angle gauge and figure out what that angle is. So if I get my angle gauge here, I try and line it up, square it up with the bottom of the robot, and then line this up with this axis, and then I can lock this down and look and see what my angle is. From 180 down to here, I can look at it and I can see I'm at 114 degrees, so that's what I'm going to put in here, is 114 degrees. Now I also need to figure out how many steps it's going to take to get from 114 up to whatever my maximum angle is. So again, I'm going to take current step, I'm going to set that to 0, and then I'll start jogging the robot up, and let's see how far up the axis can go. I'll change that to a higher amount. Okay, so that's pretty close. I got lucky I didn't overdrive it there. So I'm going to change that to 10, and let's see how far back we can go. Okay, so right there is about as far back as I can possibly go, and it looks like I'm at about 1,080 steps right now. So let's see what the angle is. I take my angle gauge here, and again I try and keep my angle gauge flat with a base, and then figure out what that angle is. Of course, you can spend a little more time than I did, but I measured it earlier. So that current angle is about 193 degrees, and it took me 1,080 steps to get there, so I'll put 1,080 steps in there. Okay, so axis 1 and 2, the step limits and angle limits are done. So you don't have to sit here and watch me fumble around with jogging the robot and figuring out angles. I did this ahead of time. Axis 3, its angle limits I found was about 137 degrees up to 206 degrees, and that took me 9,800 steps to complete that move. Axis 4, I'm going to treat axis 4 the same way as axis 1. I didn't make my wires here long enough to go a full 360, so I'm just going to go from 90 to 270, and then the amount of steps that took for J4 was 4,000 steps to make that move. Now J5, I found that when I jogged J5 in the down direction, that was about 70 degrees, and in the up direction it's about 250 degrees, and that took me 5,350 steps to make that move happen. And then axis 6 is the same thing as 4. Again, wire's not quite long enough to go a full 360, but I don't think I need that. I just need to go from 90 to 270 again. And you can make your wires and build your robot however you want, make your angles whatever you want, so you could certainly do a higher degree of rotation. So for J6 to get from 90 to 270, I found that took 3,800 steps. So I've got all of these set. So now the next thing to do is I need to jog my robot to the home position, or the calibration position. This calibration rest, its purpose is meant that if I ever lose calibration of my robot, I ever crash my robot, power gets shut off, it gets bumped to move, I can just jog it back to this rest, and then I can click this calibrate robot button, and it will instantly be recalibrated right back to where it should be. So what I need to do is jog it down to that rest, and then figure out what the angles are that the robot is in when it's in that rest. So right now that's what I'm going to do, is I'm going to jog the robot into that rest. This might take a minute. Change that to 100%, move a little faster. So now I'm going to shut the power off to my robot so that I can manually move it down, get it a little closer, save a little bit of time, and then I'll power it back on. And again, this takes a few minutes here. I'm going to turn most of these values down to smaller amounts. So now I'm trying to jog axis 5 in the up direction a little bit, but you can see I can't do it because I set my step limits in the positive direction to be 5,000, but from the previous default setting it's still at 10,000 for the current step. So I'm just going to change that current step to, let's say, 2,000. And now I can jog it. Now it's letting me jog the axis up. So the axis and angle limits will stop you from overdriving your robot in one direction or the other. So now I'm going to go back to trying to jog the robot down onto the rest. Change my speed down a little bit, that's too fast. I hit a limit here, 9,800, so I'm going to put this down to 2,000. Change this up to 100. Getting closer. Hit an angle limit, change that to 1,000. Axis 6 flat there. I need to bring 2 down a little bit. So I'm pretty close. Change that to 5. Come down one more. And then I'm right down in my rest. So I'll shut power off one more time. Make sure that I'm flat in the rest. Turn power back on. And make a couple more small adjustments. Down. Okay, so now I'm down in my rest. I'm in a good spot. I'm lined up perfectly in my rest. So now I need to figure out what angles the robot is at right now. So let me get out my angle gauge here. I can put this up against the base and up against the side of the rest to see what my current angle is, and keeping in mind that's from 180 being straight out back to here. Looking at my angle gauge, I'm at about 116 degrees, so I'm going to put in 116 degrees. Now for axis 2, I want to figure out what my angle is down from the base, how far down that is, 180 being straight up and down. So I'll take my angle gauge and I'll get it flush to the top of the robot, figure out what my angle is, lock that down, and it looks like that angle right there on axis 2 is about 152 degrees. So I'll do the same thing for 3, 4, 5, and 6, which I did ahead of time. So axis 3 is currently at 141 degrees. Axis 4 is right in the middle, it stayed at 180. Axis 5 is currently at about, let's see, what is axis 5? I need to remeasure axis 5 to see what it is. It's in the up direction. So it's at about, I'll say about 190 degrees. So I'm going to set that to No, excuse me, it's not 190. It's about 240. Sorry, do my math here. So it's about 240 degrees. It's just about 10 degrees shy of its maximum up position. And then axis 6, same thing, it stays at 180. It's right in the middle of its stroke. So now I have defined all of the current angles that it's at in its rest position, and I can hit Calibrate Robot. And what that's going to do is it's going to calculate based on all the limits I've put in. It's going to calculate degrees per step, so every time I step the robot it knows how many degrees each step is equal to, and then it calculates what the current step is given its current position, being at whatever angle it's at between these two. It will calculate current step, current angle, and the robot is basically calibrated at this point. So anytime I lose calibration, I can come back to this point and just hit Calibrate Robot and I'm good to go. Or the other thing is when I make all my programs, I always start and stop in the rest position, so it always stays there anytime it's not being run. Now I'm going to do a separate video on programming, but while we're here I will go ahead and put in a couple things. I'm going to change this to 100% speed. Anytime I teach a move, it's going to use the speed that I've set here for jogging. And then I'm going to put in this exit home button. What that does, it throws in a comment and a few moves that are all calculated off of the home position. And what that's going to do is it's just a quick button to get me up off the calibration rest, just to make programming a little easier. So if I'm here and I step through this, first move is where it's already at. Second move moves a little bit to the right, and then that moves it up off the rest. Now let's change this to 200, change my speed down to 25, and let's jog the robot over a little bit. And then let's say axis 2, come up a little bit. Okay, so let's teach that position. So click here. It's going to use whatever speed I put in, so I'm going to leave it at a slow speed, and I'll hit Teach New Position, so it puts that position in here. And then let's say I want to move back home, so I can use this Move Home button. That'll throw in a comment, a few moves to get me back home. So let's start right here and try that out. So that's going to put me above the rest, and then the next move is going to come down to the rest, and then the final move is going to be over right into the rest. So now I'm back home perfectly. So now when I run this program, I can exit out of the rest, I can move to my position that I programmed, and then I can always get right back to the rest. And there we go. So the robot is calibrated and we're ready to start programming. Alright, thank you very much.